Team Design O Mite, and we are here to present the recap. I am Frank II. This is Mr. Jackson. This is Mr. Scaller. This is Mr. Flowers. Overview. Just a little overview of what we're going to talk about tonight. First off, we have concussion. This is a problem that we're being presented. We're going to give you a viable option for a solution, which we believe will be the recap. We'll talk about the physical and electrical components of the product. We will talk about computer applications that we're going to use to interface with the actual product and how we're going to end up transmitting data from the helmet to our Android application. We're going to talk about a method that we use to actually test the product and calibrate it. And then also we will hit on our expense report of how much it will actually cost to get a recap. Then at the end we will hit on a summary of the presentation, telling you what the actually really covers. What is a concussion? A concussion is a traumatic brain injury that is caused by a blow to the head or body from a fall or something that jars or shakes the brain inside the skull. Concussion actually comes from the brain hitting the side of the skull, and that can cause bruising on the brain, and that's a huge issue. Also, the actual compressibility of the brain is actually pretty high, but the actual vessels, blood vessels that are within that tissue is very low. So bursting those blood vessels also is a big cause of concussions. Severe concussions may require surgery and lead to long-lasting problems with movement, learning, speaking, and memory loss. CTE, which stands for chronic traumatic encephalopathy, is one of the main brain diseases that are associated with brain trauma and concussions. This has become more and more of a deal, of an issue in the NFL as we are seeing more and more fines given out for vicious hits and targeting. Concussions are common, particularly if you play a contact sport such as football. Here are many symptoms that are associated with brain trauma and CTE. I actually had the opportunity to sit in on a lecture actually in this room by Dave Halstead. Dave Halstead, he's been working in the safety industry and with impact biomechanics and sports biomechanics for a long time. If you actually look at most football helmets, you look on the back of the helmet, there's all these organizations and committees that help with the safety of football products. I think they do for helmets, with lacrosse, football, softball, baseball, and making for safety reasons. And he's on pretty much all of those committees, so he's a huge deal when it comes to that. I got to hear him speak, and one of the things that he said was a huge issue with causing, that's where I actually learned about the compressibility of the brain tissue versus the blood vessels, why that's a cause of concussion, and also the high G-forces that are generated in such a small space is really what can make them so dangerous. Football is the most common sport with a concussion rate of up to 75% for athletes. Retired NFL players in their 50s are 5 times more likely to be diagnosed with concussion, and retired NFL players in the age range 30 to 49 are 19 times more likely to be diagnosed with concussions. I feel like that goes to show how football is becoming increasingly more violent sport. People are training at earlier ages, and they're getting bigger, faster, stronger, and being able to actually generate more force on the field when they're striking each other. I feel like that's a huge reason why that's coming up, and also with medical technology being able to catch that. In the 2013 NFL paid $765 million settlement to 2,000 players that are suffering with these types of brain injuries later on in life. And we're not aware of the effects beforehand. And studies show that 56 out of 100 NFL players will try to hide concussion symptoms if it would keep them from playing, which is huge. You know, when we get to the NFL, these guys, this is their livelihood, this is what they do for a living, this is what puts food on the table for them. And if they're not able to do that, that competitive mentality is just going to want to push through it and get the job done, when in fact that can be more detrimental than beneficial. Yes.
My name is Stephen Gass, and I want to go over the components that are inside the GCAP and how it works, and we'll start it right now and show on the picture. All right. In the back, we have a couple batteries. Up here in the front is an accelerometer, and back here in the back part of the skull in the cap is an Arduino board and a Bluetooth transmitter. very small. We wanted to minimize the amount of room we had, took up inside the helmet, so it didn't affect the player whatsoever as far as what they do and weight issues like that. So actually, inside the GCAP is an accelerometer with an Arduino processor, a Bluetooth module, and 2 batteries. How this works, so the overall big picture. A collision happens. The collision is sensed by the accelerometer. The accelerometer then sends its 3-axis X, Y, and Z components. It sends them to the Arduino. Arduino then determines the magnitude and direction of the hit, determines that the hit was substantial enough to be transmitted out, and if the hit was over 50 G's of force, it will then transmit this back to the sideline, where a trainer will have an Android-based tablet that can receive the data and then make a judgment on whether they think the player should be analyzed or not. The Arduino processor is actually on it's huge here, but it's only about an inch high, 2 inches. It only takes 3.3 to 5 volts to operate, and it has 14 digital outputs, 8 analog, and it only runs on 40 milliamps of power, which is pretty low. We can sustain that with battery power. The triaxial accelerometer is actually only about the size of a postage stamp. It's only about an inch by inch square, and it's only about an 8-inch thick. It runs on real low power, only 300 microamps, so it actually doesn't take hardly any of the battery power at all. And it uses a very small range of 1.8 volts to 3.6 volts. The accelerometer has a 10,000 G shock survival rating, so I don't think anybody's going to come close to that anytime soon. So it should be alright. The Bluetooth transmitter is about 4 inches by about ½ inch. It's relatively small. It's a Class 1 Bluetooth transmitter. Class 1 can go up to about 100 meters, and which covers pretty much football field. If the trainer was standing at the 50-yard line, it could cover all the throws back corner of the end zone and then some. It also operates at a low voltage, and its power consumption when it's not transmitting is very low, and when it is transmitting, it's only transmitting around 30 milliamps, so you can sustain a while on battery. The batteries we chose are 2 lithium-ion batteries. They're both actually very small and very thin. They each are 3.7 volts, and they have 350 milliamps. The Bluetooth uses active rest, and so does the Arduino to conserve battery power. So it's not when it's not being read, it's actually using very little power. Now this is a better picture now that you've seen the actual components. So it's back here, behind this padding here, you have the Bluetooth and the Arduino. Up here at the front is where it would sit around the top of the head. So if the player was standing, vertically upright, the Z would be up, and X and Y would be straight in front of you and to your right. And back here are your batteries, which are out of the way, and behind. And all the wiring is done behind the pad, so they do not interfere whatsoever with the player's ability. And this is the Samsung tablet. I'm going to turn this over to Mr. Scally.
Good evening. My name is Marcus Scally. I'm going to talk a little bit about the tablet side of it, what happens after the data actually gets to the tablet. For our project, we went ahead and went with the Samsung Galaxy Tab 3. No real reason for it. It's just a very economical tablet to have. It runs Android 4.2 Jelly Bean. It has 16 megabytes of memory that we could use. We're going to be taking all this information and compiling it into a bunch of text files so we can keep logs and records so medical professionals can actually track a player's career and see how they got hit, where they got hit. And there's a lot of text files you can put into 16 gigabytes of RAM. It has the Bluetooth version 4.0, which is called Bluetooth Smart. It actually uses BLE Bluetooth Low Energy that was developed in 2011. Just another power reserve that we have. Another way to cut back power costs in our design. We went ahead and used the Android SDK library with the Eclipse compiler, just like the all-in-one use. Uses the integrated development environment, so we can go ahead and test on the computer, then put it onto the tablet and make sure it works just fine. What actually happens when we set up our tablet, we create a handshake. The tablet says, I'm ready to talk to you for a little while. The Bluetooth transmitter says, all right, we're good, and then a secure channel is actually reached. The Arduino then enters an active rest stage. The active rest stage is a way for us to conserve battery power. We're going to set a threshold of about 50 Gs, and any hit that's under 50 Gs, we're not going to be transmitting at all. It's going to sit idle. Once that 50 G threshold is reached, that's when we're going to burst transmit data. This allows us to use very little battery power. These batteries can last a very long time. The data is then written into a normal text file, and that text file is then displayed for the medical professionals to actually see. We brought this information from the National Institute of Neurological Disorders and Stroke, and this is where we got our 50 G threshold. From their research done in 2002, they said that most hits below 50 Gs not going to make a big difference. Once you get 50 G to 90 G range, you're looking at some problems, and it might cause concern, especially if there have been multiple hits in this range. That's when you can actually run into some problems, and a medical staff will look at it. This 90 G and up range is where we have some serious problems, and that's when the medical professional can actually pull the player off the field and do more tests. And this is the actual application design, which you can actually see running right here as well, if you can see it, or up here. This shows that somebody initially got hit very hard at 171 Gs, maybe the running back was running into the line. The bounce back happened, and then he actually ended up getting hit a couple more times. This would be something very serious that the medical professional would actually look at, because this happening right here is not so good. It actually takes the X, Y, and Z coordinates that we get off the accelerometer, calculates magnitude like all of us can do, and then plots it for 60 milliseconds. What we actually designed was another way to help the medical staff, and we actually showed the direction of the force that it came from too. A lot of times people can get hit in different directions, and that's going to cause different injuries. We might be able to even detect jaw fractures, skull fractures in different areas of the head. I'm going to turn it over for our testing procedures to Mr. Jeremy Flowers.
Thank you, Mark. Good afternoon, ladies and gentlemen. My name's Jeremy Flowers, and I'm going to wrap things up for us. I'm going to start off with the test apparatus. Why is testing important? Well, I'm going to tell you why it's important for this application. Got a player on the field, and it says he got hit with 100 Gs. Did he really get hit with 100 Gs? Just because our GCAP says 100 Gs? Is that really what he got hit with? So what we did, just to test that for quality control purposes, we constructed this pendulum swing test apparatus, and basically it has 3 pre-drilled mounted holes in this height right here, in the swing arm, and knowing the height, the weight of the helmet, and the position of the helmet, we're able to use physics to determine the force of the impact right here. So use that. The shortest rung was 80 Gs, 70 or 80 Gs. The second was 120. The last one was all the way to 200. So right here, it goes from jumper range from 50 Gs to 200 Gs. Another important to note is that we can rotate the football helmet to hit at the front of the crown or in the absolute rear of the crown, and we're able to go inside and move around that accelerometer and see what our readings are like. How far is the deviation going to spread? We had to maintain 10 G's deviation, which we were able to do. How much does the GCAP cost? So just before I continue, actually show the actual value, I just want to say that Stanford and MIT has actually already produced and is actually selling this product. However, it's well over $1,000, and it's more designed and more pointed towards Division I and pro football teams. So with that being said, our product is roughly $273. However, we got to consider that this tablet that we use is also included. So we're looking more at $130, $140 price when it's all said and done. So our original microprocessor about $10, Bluetooth modem 65, accelerometers about 30, and our 2 batteries about $18 each. And like you said earlier, Samsung Galaxy tablet was $150, total up to about approximately $270. So just a summary of what we talked about today. What is a concussion? Concussion's a big deal. As we all know, most of us probably right here like sports. We like follow football, other sports as well. It's a pretty big deal. People are getting hurt. We should see it every single day. What is GCAP? GCAP is something that we designed to try to solve this real-time issue. How does it work? We went through the components, how everything's integrated together. What's it made of? Same thing. And how much does it cost? Questions, comments, concerns? That's actually two Citadel football players in the early 90s trying to cool down. Also, I'm sorry, before I answer any questions, I would like to give a huge thanks to Dr. Skinner and a huge thanks to Mr. Bartnett helping us out. Couldn't have done it without you guys. Thanks a lot. Appreciate it. Questions, comments, concerns now? Go ahead.
Y'all using it for a football helmet? Could you integrate it into like a hockey helmet or any other type of headwear?
Absolutely. You can take out the helmet and you can put it in any other helmet that you deem necessary that you want to do. Absolutely. Yes, sir.
We get you put the helmet on, have teeth hit you and see.
Absolutely not. Absolutely not. So that 170G tape you saw earlier came from the big one.
I got a question.
Yes, sir.
Who dressed as you guys?
I'm a very, very stylish person.
Looks good.
Anything else, guys?
Was there any concern about damage to the batteries?
There was.
We had the concern. We just didn't worry about it. No, but that's why it's placed in the back.
Okay.
Batteries catch on fire?
No, we lit some stuff on fire, but it wasn't bad.
That
Curtain's actually pretty crazy sometimes.
We did do some research on lithium-ion accidental discharge, though. Hopefully it doesn't.
I'll give you that one.